the stomach that are producing the acid. So you also have what's known when the stomach is producing acid, you get a corresponding release of bicarbonate into the venous blood. And that's actually known as the alkaline tide of digestion. Okay, so the function of the stomach is to release certain enzymes like pepsinogen, which then gets cleaved by the acid into the active form of pepsin. It's a protease. It also, the acid activates the lingual lipase, so it ends up breaking up connective tissue and breaking down proteins. You get conversion of iron in the +3 state to the +2 state so that it's useful in being incorporated into red cells to form hemoglobin. And the acid obviously helps to destroy any ingested bacteria. But some bacteria can end up making their way through, particularly when you have billions and billions of bacteria. So there, I guess, is hope for the probiotic industry, because we'll see that the microflora found within mostly the large intestine is actually very important for absorbing food that you are not able to digest on your own. Many of those bacteria have enzymes that humans aren't capable of producing, so the wider variety of the bacteria that you have in your microflora, the more potentially food you can digest and be able to absorb. So it turns out individuals who are obese have bacteria that are particularly well suited to digesting food material that has made its way through the small intestine without being absorbed, and they can break them down into molecules that you are capable of absorbing. All right, so the rate of emptying of the stomach, so you can see only particles less than 2 millimeters are allowed to pass through the pylorus, so that it tries to limit the amount of food being delivered to the small intestine. And remember, the small intestine is by far the largest part of the digestive tract. You have the 3 portions of the small intestine: the duodenum, the jejunum, and the ileum. And during those 20 feet, you get absorption because you have a lot of the cells that have microvilli, and you have transport mechanisms so that various like monosaccharides as well as fatty acids and monoglycerides can all be absorbed. And we'll see a lot of that material ends up going directly to the liver via what's called the hepatic portal system. So a portal system, as you recall, is having 2 capillary beds in a row. In this case, the first capillary bed is within the GI tract. So you have capillaries within the stomach, the small intestine, and the large intestine, all sending material through the blood vessels. Ultimately, they make their way to the portal vein and then into the liver capillaries, where all of the different cells within the liver are then able to process the materials that comes their way. So all of the basic amino acids from protein digestion, the fatty acids from fat digestion, together with the glycerol and other materials, are making their way to the liver, which then is able to process them. And we'll talk about the multiple functions of the liver. So a couple of the accessory organs of digestion that we'll see include the liver, the pancreas, gallbladder, and we'll go over the individual functions of each one of those coming up. So hydrochloric acid in the stomach has to be neutralized when it gets to the small intestine. In the stomach, you have that mucus layer that helps to protect the cells within the stomach. One of the things that can actually disrupt that protection, for instance, is taking aspirin, because the secretion of mucus is dependent on prostaglandins. And aspirin, as you recall, inhibits cyclooxygenase, so it prevents some of those prostaglandins from forming, so it can disrupt that mucus secretion. So by doing that, it sort of destroys the protective effect of the stomach lining, so that it allows the acid to potentially erode and end up giving patients GI bleeds. So the erosion of the stomach lining allows blood vessels potentially to be opened up and to be infiltrated, and that can allow bleeding into the lumen of the stomach, and that can literally turn your feces black, and that is known as melena. So if the blood is coming from the upper GI region, which includes the esophagus, stomach, and even portions of the small intestine, it has a chance to get digested and it turns black. So when the hemoglobin and blood makes its way through the GI tract, it's subjected to a lot of enzymes and breakdown, and you end up getting black tarry stool, which has a very characteristic odor and shape or composition. All right, so here you can literally see the mucus layer that's on top of the stomach. The stomach also has secretion of bicarbonate near those cells, and it helps to protect any acid that gets through. So the alkaline mucus helps to resist the acid that is being secreted by certain of the stomach cells. And as I said, the NSAIDs and the NSAIDs include aspirin, ibuprofen, but not typically Tylenol. Tylenol doesn't affect the prostaglandin formation because it doesn't inhibit cyclooxygenase. So these are some of the different functions that you can see that prostaglandins have when cyclooxygenase produces things like thromboxane. It activates platelets. It causes mucus to be secreted in the stomach as well as bicarbonate. So it does a lot of things. So anytime you take aspirin, it can have potentially deleterious effects. And that includes on like certain non-steroidals, aspirin not really, but ibuprofen can actually have problematic effects occurring in the heart. And in some cases, individuals who have taken non-steroidal drugs end up getting heart attacks and problems because of that impairment of cyclooxygenase. Okay, so the enteric nervous system has about 100 million neurons, and they're capable of many different functions: information processing, motor output. So it's a very complex system that is in addition to the regular nervous system that you have. And it also, you have endocrine effects. So the endocrine system helps to coordinate the functioning of the GI tract together with the autonomic nervous system. And if you look at the presence of different neurotransmitters, for instance, serotonin, which is sort of the feel-good hormone, is 90% of the serotonin found in your body is actually found in your gut, as is 50% of the dopamine. As I said before, when psychiatrists give antidepressants or other medications, they can have profound GI effects, as can different diseases like diabetes. Diabetes, because you get effects on different nerves, particularly the autonomic nervous system, it also affects GI function. So in many cases, diabetics complain of either constipation, diarrhea, or other issues with their GI tract. So there could be a lot of problems based on disruption of either the enteric nervous system or the autonomic nervous system. All right, you have a number of different programs, and your GI tract is constantly undergoing peristalsis as well as secretion of mucus and other substances, and you have programs that are literally keeping these things going. So when a physician puts a stethoscope onto your abdomen, they're constantly going to be hearing bowel sounds. And as I said in class, those bowel sounds are going to be caused by turbulent flow of the air-fluid interfaces. So as the air moves back and forth and the fluid moves back and forth, you actually can hear those interactions in the form of bowel sounds. And physicians have given those bowel sounds names, and they actually are called borborygmi. Not that you have to know it, but there are various different both fasting and fed programs that have certain things occurring within the GI tract, and they occur when certain substances enter into specific regions, like either into the stomach or to the small intestine. The hormones that are particularly important include this one, which is called cholecystokinin. Cholecystokinin is going to be, the release of it is stimulated when fat enters or other, even protein enters into the small intestine. That causes the release of cholecystokinin, and chole refers to gallbladder. So cholecystokinin causes the gallbladder to contract. And we'll see that the gallbladder is a storage repository for bile. And bile is an emulsifying agent. And what an emulsifying agent does is it breaks down large particles into many smaller particles, so that, particularly in the case of those particles have fat within them, you're able to allow enzymes to come in and be able to get to those fat molecules and be able to digest them. So it also causes release of sphincter known as the sphincter of Oddi, which is the region where substances from both the pancreas and the liver enter into the small intestine. So it opens up that sphincter and allows both bile as well as enzymes from the pancreas. And we'll see that the pancreas has both endocrine and exocrine function. The endocrine function of the pancreas includes releasing insulin as well as releasing glucagon and other hormones like amylin or somatostatin. The exocrine pancreas releases hormones, and those hormones include amylase, so you have pancreatic amylase, pancreatic lipase. There are a number of different proteases, including procarboxypeptidase as well as others. So there are nucleases, collagenases, so there are a lot of ACEs that are released by the pancreas. And one of the things that can happen to individuals is they can get pancreatitis. And what pancreatitis involves, particularly if you drink a lot of alcohol, you can irritate your pancreas such that you cause disruption and apoptosis or necrosis of some of the cells within the pancreas. And when those cells release their enzymes, you can start auto-digesting your own organs. So it can be a particularly lethal disease, and the mortality from pancreatitis, if it's untreated, can actually approach over 50%. All right, and this shows what a normal pancreas looks like as opposed to an inflamed and angry pancreas. And pancreatitis, they typically have to put that individual, not allowing them to have any food intake, so they put the abdomen at rest, and they literally have to feed that individual through the venous system or other methods. So causes of pancreatitis, as I said, can be ethanol. You can also get it if you have a gallstone and the fluid backs up within the pancreas. Idiopathic basically means the physician's an idiot, or no, it means that they don't know what's causing it. Trauma can cause it, even taking too many steroids can cause it. Scorpion sting, that's a new one on me, but that can also cause it. And one of the classic ones is actually hypertriglyceridemia, which for whatever reason causes the pancreas to become very angry and inflamed. So these are some of the different enzymes that are produced in the small intestine. You can see that you have salivary amylase, pancreatic amylase, or those are produced by the pancreas and salivary glands. Small intestine includes the disaccharidases, so you have maltase, sucrase, and lactase. And remember, we said, what is lactose intolerance? Lactose intolerance means that when you take in lactose, the enzyme that digests it, which is normally within the small intestine, is no longer there. So when the lactose makes its way through the small intestine, it goes through intact, and when it hits the large intestine, the bacteria start digesting it. They produce all sorts of gases like methane as well as others, and the lactose literally draws fluid into the intestine, so literally you start farting and you start having diarrhea. And that's what lactose intolerance is like if you've never experienced it before. The pancreas secretes lipase as well as amylase. You can see each one of the organs secretes different enzymes. In the pancreas, you have trypsin, chymotrypsin, carboxypeptidase, and each section typically secretes a particular substance that helps to break down the various different foodstuffs that you take in. In the large intestine, you don't typically have the cells releasing substances, but rather the bacteria that are using the materials that reach them, and they digest them and use some of the materials for themselves, but other materials can actually be absorbed by you. And different individuals, if they have different diseases, have been found to have a specific type of bacterial microflora.